Welcome to the binary search experiment. In this experiment, we will go through the concept of sorted arrays, and we'll learn about another algorithm which is a little faster than by linear search. So let's take a look at what sorted arrays are. So when the elements of an array are arranged in either ascending or descending order, they are said to be sorted. So let's take a look at the example. We have 16, 5, 2, 12 and 8. They are arranged in some random order, but say if we arrange them in the increasing order of their value, then that is 2, 5, 8, 12 and 16, they're said to be sorted. Alright, so now let's take a look at the problems with linear search. So in linear search, we need to go through all the elements of the array to find to search for the query element, the element that we want to find. So the time complexity is a lot in this case, because it's a very time-consuming operation for a very frequently performed process. Searching is very frequently performed in any application. Then so we have a requirement or a need of something faster, some faster searching algorithm. So we have an idea that what if our array was sorted before we search. So once the array is sorted, we can reduce the number of elements we might have to do, we might have to compare or look at to search for a particular element. So then comes the intuition for binary search. So in binary search, what we do is we search a sorted array by repeatedly dividing the search interval in half. Then we start with an interval covering the entire array. If the value of the search key is less than the item in the middle of the interval, then we reduce the interval into the lower half of the array. If not, then we reduce the interval into the upper half of the array. Then if the search key of the element of the middle element matches the query item, then we have found our element. So for example, we have 2, 5, 8, 12 and 16, and we have to find 12. So what we do is first we look at the middle element. So this is a sorted array, which is a prerequisite to the binary search. So we look at the middle element of the array, which is 8. We see 8 does not match with 12. So what we do is we know another thing that we know is 8, the value 8 is smaller than that of 12. So that information gives us the information that our element 12, if we have to find in the array, will always be in this part of the array, and we can safely discard this much of the array. Then we take a look over here. We see look at the middle element of these two. So the middle element of these two will be 12, and we compare 12 with our query element 12. We found a match, right? And so we return the index of this element.